Hello, my name is Jeff Overwine, and today I'm going to walk you through how we use Epicor's advanced MES to really drive efficiency around scrap and production. So the parts that I'm going to focus on today are around our SPC SQC application, which stands for Statistical Process and Statistical Quality Control. Now, within this, we have really three aspects of this. We have the ability to automatically collect process data. So in this example here, I'm going to focus on an injection molding machine. And within that, we're measuring cycle by cycle things like cycle time, fill time, pressures, temperatures. So I'm looking at injection pressure. I'm looking at things like my mold temperature. And as those deviate, I want to be able to capture that. And I want to statistically be able to say that, hey, it went outside of a control limit, it went outside of a spec limit, I'm shifting, I'm trending. And as those conditions happen, I want to do adverse things in our system. And one of those is called part qualification. And what that means is that I'm relying on those process conditions to tell me if that's a good part or a good shot, and I want to automatically scrap that if it deviates from that. So that's called part qualification. But we also tie into other systems like vision systems. So as the part's manufactured, uh, maybe it goes on a conveyor and it goes through a system to where it's looking for flash or scratches and things like that, and it it analyzes that information, stores it into a PLC to where we can read that. The other thing that we can do, we can manually enter those types of characteristics. So maybe I'm an operator and I don't have a vision system, but I'm the one visually inspecting that. So with variable data allows me to, uh, record those different reactions based upon what I'm measuring. So if it's ID, OD, length, weight, things like that, I can measure those characteristics, and we'll talk about how we do that in the system. Likewise, maybe I have a way of documenting pass-fail type situations, and that's what we call attribute data. And then finally, we'll talk about the data analysis, the different screens and tool sets we have in the advanced MES that allows us to analyze the end results. So let's take a look at it. So where I thought I would start is the real-time screen. So in this real-time screen, it's providing feedback on what's happening on the shop floor right now. So this is the current shift and how we're currently producing for the current shift. And the emphasis that I want to focus on are things like my scrap percentage, my scrap parts, and my processes and how they're performing. Now, this is just one example of a screen that I want to look at and analyze. And I can go in here, for example, if I wanted to look at a Pareto of my scrap, I could very quickly do that, and I can analyze this for any shift and get an idea of where my scrap is or what my percentage is. I have, interest in that. But if I wanted to look at how I'm performing cycle by cycle, not only for cycle time, but for any process data point that I'm measuring, I have the ability to do that. So if I wanted to read not only my cycle time, but my injection pressure as well, I can click on that and I can read that in the same chart or in multiple charts, and I can do that for as many process data points as I want. I'm analyzing this for the last 500 cycles, but I can go back and look at my last 100,000 cycles if I wanted to. And in addition to, reading this data, I time and date stamp each one of these. So here's my time and date stamp associated to this particular point that tends to be deviating in the process. In addition to that, I can look at raw values and I can look at X bar and R chart of how I'm performing cycle by cycle with any process condition that I want to analyze. So from the real-time screen, all I did was double click on the actual speed value for that machine to analyze that further. If I wanted to get more into a statistical analysis of the process, I could right click on the screen and launch that. Or I could create another screen that reflects, how I'm performing. So maybe I want to look at this type of screen. And you can see here that the data that I'm looking at now focuses on all the processes that are happening cycle by cycle. And as these deviate, that color, the colors change. So as I go outside of a spec or a control limit, or if I'm shifting or trending, these colors will change to reflect that. And I could once again click on each one of these values to really dig in deeper to the data. So the emphasis behind this is we're relying on our processes, and we're relying on things like vision systems to tell us if the product is good or defective, and define that process. So let's kind of take a look at how we configure this system to configure for part qualification. So in our system, we have the concept of what we call a process sheet. So what's unique about this process sheet identifies how this part should perform when it uses this tool on this machine. So our standard cycle time here is 9.5 seconds, for example. But as I navigate from left to right, there are various aspects that drive our SPC-SQC application, and tells us how we want to collect the data and analyze the data, and what type of actions we want to do with the data. So these are user-defined spec limits that we associate to the data that we're collecting. So I would have to go in here and manually key in this data or bring it in from another database. As I go to my control, these are calculated values. So I can say, hey, I just started this job, and over the next half an hour, I want to collect the data, and I want my control limits based, and I can define the method in which I calculate my control limits and the sigma multiplier that I can use to calculate that. In our SPC settings, this is how we statistically tell the system how frequently we want to measure the data and what type of characteristics I want to associate to this process sheet. So when I measure that manually out there on the shop floor, it identifies what characteristics that I'm measuring. And then finally, we get into SPC enabled. This is how we define how we want to configure and what we want to enable our alarms on. So when I alarm in SPC or on my process alarms, these are the conditions that I want to alarm on. So if it goes outside of my spec limit or control limit for these processes, this is what I'm going to alarm on. So visually, I can show you that in my real-time screen. Audibly, I can enunciate that through a voice board. We can send text and email to individuals when I exceed these alarms, and identify that. Now, part qualification is the aspect that we were talking about initially. So this allows us to say, hey, when these processes go out, and if it goes outside of these specs and these checkmark control limits, that's where I want to do an adverse reaction. So in this case, maybe I'm going to fire an output that tells the robot to pick that part up or those parts up and put that into a different area, and then automatically scrap that in our software. So once again, now we're relying on these process and how we define the limits, specification, and control limits. And if it exceeds those, that's where it's going to automatically scrap the product. So once that does, let's take a look at how we analyze that information. So once again, from the real-time screen, we have the ability to drive different types of conditions. So as I mentioned, cycle by cycle, I'm analyzing various things like fill time. And I can look at that in an XBAR chart. The last one I looked at was a histogram. But I can go in here and I can analyze that multiple ways. So if I go into view, SPC SQC chart, I can look at that in standard deviations, median range, moving range charts, histograms, and things of that nature. I can pull reports on that like I did last time. I could pull that up by job, by part, by tool for any time period I want, not for just the current shift or the current job, but for any time period that I want. And once again, being able to analyze any of those conditions when it happens, and statistically see how I'm performing. And then finally, we have the ability to measure those various characteristics after the part's manufactured. So in this case here, I'm measuring ID. So if I was an operator and I was out there on the shop floor, I would use a device called HMI. This just stands for Human Machine Interface. Now this particular screen is web enabled. and it runs on things like a tablet. So this is where the operator could go in, and if they were visually inspecting that, and they had an issue with scrap, and it was they had a lot of scratches on it, they could go in there, identify the quantity and the reason, and they can manually enter that. Like I said, we can rely on vision systems to potentially do that as well. But in this aspect, not only are they looking for that, but they want to document, once an hour I want to go in here and I want to measure those characteristics. So in addition to having visibility into how my processes are performing as I'm manufacturing that, I also have the ability to enter that data and statistically see how I'm performing. So from the process standpoint, I can go to any one of these data values from cycle time to a pressure or a temperature and see how I'm performing. And then finally, once that product is actually manufactured, I want to go into this variable table and I want to define what it is that I want to measure. So now I have this part, and this part, I want to be able to statistically enter in the direct results. So I can go to my entry key. Now, this is where we potentially might have a Bluetooth caliper or micrometer or a scale to where it's interfaced, and all I do is hit the send button. But in this case, I would just, when I hit the send button, it would key in what the value is. So 22.5 millimeters. Now I'm measuring the next part, and that value is 23 point, 7 millimeters, and then the next one that I measure is 24.6. So once I hit update, that saves that, and then maybe after I hit save, I want to measure the next characteristic. So I could go in here and say, now I'm looking at the ID of the product, and then I could enter that date. So once I enter that date, I have the direct results of what that is, and I can look at that right here from the HMI. So once that's saved here, it's then pushed into our database to where we allow us to analyze that and statistically record that. But all those direct results are being recorded in the software for us to analyze it through our statistical software here, our package here, or in our real-time screen. So I could go here and analyze how we're performing for the current shift any day. And then finally, there's other tools like using reports to analyze the information, to using things like a BI application like Epicor Data Analytics. But anyway, these are just some of the methods we have built into the application that really draws an emphasis around reducing scrap and gaining and leveraging the different tool sets in the application to improve efficiency around scrap. Anyway, thank you for your time. Have a great day.